Today's lesson is Module 5, Lesson 1, Area of Parallelograms using rectangle facts. The first thing we're going to do is review what is a parallelogram. A parallelogram is a quadrilateral with two sets of parallel sides. If you can't remember what a quadrilateral is, it's a shape with four sides. That word quad means four. We're going to be talking about three different types of parallelograms. The first one is a parallelogram, and I'm going to draw one of those for you. So you'll make two parallel lines that are slightly slanted, and then connect the top and the bottom. These two lines are parallel, and these two lines are parallel. The next shape is a square. Remember, a square, all sides are equal. And again, a set of parallel lines and a set of parallel lines. And finally, a rectangle. A rectangle has opposite sides are the same measure and are parallel. Now we're going to move on to the formula to find the area for a parallelogram. That formula is area equals base times height. So very similar to length times width, what we used in our last module. You can abbreviate that as A is equal to capital B times H. With a parallelogram, so one that kind of looks like a square or rectangle that's been pushed over, so to speak. This bottom part where it sits is called the base. The height is from the top all the way down to the bottom. This is called the height. Sometimes a parallelogram will have even a sharper tilt. So it could be something like this. This is still the base. But we would find the height a little differently. We would come to this outside point and we would measure all the way down and then take this last point here and come across, and then this would be the height. You can kind of think of it as three rectangles. The shape itself doesn't change, but if I were to straighten it up, that would be the height from the top point all the way down to where the bottom is. So the area, the amount of space it takes up is not going to change because the shape itself is not going to change. So let's come back to this and we're going to do some practice. So if my base was 5 centimeters and my height was 3 centimeters, then to find the area, I would first write out my formula, area equals base times height. And then I'm going to substitute in these two measurements for the base and the height. So then I would write area equals 5 centimeters, which is my base, times 3 centimeters, which is my height. I'm going to combine like terms by multiplying. So 5 times 3 is 15, and then centimeters times centimeters I know as centimeters squared. So the area is 15 centimeters squared. And we talked about in the last module how area will always have its units squared. You can go ahead and put your notebook to the side. You may not want to put it all the way away. Now we're going to get into our student book. And in your student book, I want you to go ahead and open up to page S1, which will be Module 5. So it will say 6.5 at the top, Lesson 1, the area of parallelograms through rectangle facts. And the first thing we're going to do is we're going to name each one of the shapes that are in this opening exercise. And I will use the facts that I know. So since this shape has 3 sides, I know it's going to be a triangle. But this box here indicates that that angle is 90 degrees. So therefore, this is a right triangle. The next shape has 2 sets of parallel lines. So I know that that's going to be a parallelogram because it has 2 sets of parallel lines and it looks like it's been pushed over on its side. The next shape, again, has 3 sides. I don't know exactly if these 3 sides are the same measure. There's nothing to indicate that to me. But I can see, just by eyeing it, that each one of these angles are smaller or less than 90 degrees, but more than 0, which makes them acute angles. So this is an acute triangle. The next shape has 2 sets of parallel lines, so I know it will be a parallelogram of some sort. And I can see that my opposite sides are the same length, so that indicates to me that this is a rectangle. And last but not least, this quadrilateral has 1 set of parallel lines, and it's a closed shape, making it a regular quadrilateral, and this is called a trapezoid. Now the next part of our lesson will be us applying the formula that we learned in our notes. So for exercises 1, A through C, what I want you to do is find the area of each parallelogram. Remember that its area equals base times height. So go ahead and pause the video, work with someone who's close to you if you would like, and see if you can figure out the area of each one of these shapes, and then we will come back and discuss that. So go ahead and pause. Okay, so let's go ahead and review this. My base on the first shape is this bottom number here, which says 6 centimeters, and my height is the 4 because it's written right next to the dotted line indicating that. So area equals base times height, so area equals 6 centimeters times 4 centimeters. 6 times 4 is 24, and centimeters times centimeters is centimeters squared. On the next shape, 25 meters is my base, and 8 meters is my height. So area equals base times height. I substitute in 25 meters for the base and 8 meters for the height. And 25 times 8 gives me 200. And meters times meters is meters squared. On this last shape, my base is 12 feet. My height is 7 feet, as indicated by this line that comes down and makes this right angle. Area equals base times height. So I substitute in for base 12 foot. I substitute in for height 7 foot. So area equals 84 feet squared. Let's go ahead to the next part of our lesson. In this part of the lesson, it says to draw and label the height of each parallelogram. Use the correct mathematical tool to measure in inches the base and height and calculate the area of each parallelogram. I'm going to go ahead and change this to centimeters because I think that centimeters is going to be a little bit easier for us to measure. So the very first thing I'm going to do is I'm going to draw in where I will measure the height. So I'm going to add in my height to indicate where I will be drawing in my height for each one of these so that it will be easy for me to go in and write in this measurement. And on this last one, I'm going to need to extend this out. And this is going to be my height. So I want you to use the centimeters on your ruler and go ahead and measure those out. So pause the video, measure that out, and then come back and double check your measurements with mine. So you should have found that the base of A was 4 centimeters and the height was 1 centimeter. The base of B was 3.5 centimeters and the height was also 3.5 centimeters. And the base of C was 1.5 centimeters and the height was 2.5 centimeters. Now go ahead and pause this video again, determine the area of each one of those 3 shapes, and then come back and check your work. So after calculating, you should have found that the area for A was 4 centimeters squared. The area for B was 12.25 centimeters squared. And the area for C was 3.75 centimeters squared. Now we're going to go on to the last one, number 3. It says if the area of the parallelogram is 35/42 centimeters squared and the height is 1/7 centimeters, write an equation that relates to the height and the base and the area of the parallelogram. Solve the equation. Well, remember the formula is area equals base times height. So if I plug in each one of these that I know for something in the formula, so if I know that my area is 35/42 centimeters squared, is the same as base times 1/7. So now I'm going to use my same 3 steps for solving any equation. I'm going to isolate my variable, use inverse operation, so I'm going to divide 1/7. This will cancel out, but I have to also divide the other side. So 35/42 divided by 1/7. So I'm going to do my keep, change, flip. So now I have 35/42 times 7/1. Now I just multiply straight across. 35 times 7 is 245. 42 times 1 is 42. So now I do 245 divided by 42. 42 goes into 245 5 times, 210 with 40 seconds left. And I can reduce this to 5, 6. So my answer for my base is 5 and 5, 6. For today's assignment, you will work on the problem set. On number 1 and 2, they just want you to draw in where would you find the height. On 3, 4, 5, and 6, you're calculating the area. On the back, you're going to calculate the area for numbers 1, 2, and 3. Remember, you can pause and rewind this video as often as you need to, or feel free to see me if you have any questions.